Hi everyone, this is going to be our new lesson on lesson 92. 92A is going to be due tomorrow. Well, at least the questions will need to be posted on 92A by tomorrow morning on Tuesday at 9 a.m. onto the comments of this video. So for this lesson, we are going over something called boat in the river problems. And there's a couple new equations, actually two new formulas that you're going to need to know and memorize. So I'm gonna write both of those down. So one of them is for when your boat is going downstream or down the river. There's a downstream equation and there's an upstream equation. Now our downstream equation will be B plus W times TD equals DD. Now my B stands for the speed of my boat. The W stands for the speed of the current. My TD is going to be my time downstream. And my DD will be my distance downstream. Now my upstream equation is going to look almost exactly the same, but instead of B plus W, I'm going to have B minus W times TU equals du. Now, just like the other equation, your B is going to be the speed of the boat, and both of those B's will be the same. Your W will be the speed of the current. TU will be the time upstream. And du will be the distance upstream. Okay? And we will need to use both of these equations simultaneously in order for us to solve this problem. So what I'm going to do is I'm going to walk us through the example 92.1, and then I'm also going to do 92.2, and then give you guys time to try and solve the other ones on your own. So for 92.1 on page 383, it says Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. Well, they give us a couple things in that. It says 60 miles downstream. That means that my distance downstream is going to be 60. And it says in the same time that it took to go 20 miles upstream. So the time downstream is going to be the same as the time upstream. Also, it says that the distance upstream is going to be 20. Okay. And then it says if the speed of their boat was 8 miles per hour in still water. Okay, so it says the speed of the boat is 8 miles per hour. What was the speed of the current and what were their times? So I'm looking for my speed of W. I'm also looking for the time down and the time up. So what I'm going to do is I'm going to take all of these variables and I'm going to plug it into both of these equations. So I'm going to start with the downstream equation. That equation is B plus W times TD is equal to DD. Now my B is equal to 8. I don't know what my W is, so I'm just going to leave it as W. My TD is equal to TU, and my DD is equal to 60. So now what I want to do is I'm actually going to distribute this TU, and that would give me 8TU plus WTU equals 60. And at that point, I'm done with that equation. There's nothing else I can do with that equation, so I'm going to leave it like that. Now I'm going to go to my upstream equation. I'm going to do the same thing, but I have B minus W times TU equals DU. Now my B again is equal to 8. My TU, because I changed my TD to TU, I'm going to leave TU as TU, and my DU is equal to 20. Now, just like on the last one, I want to distribute my TU, which would give me 8TU minus WTU equals 20. Now, if you look at these two equations, I have one of them has positive WTU and one of them has negative WTU. So what I'm gonna do is I'm gonna add these two equations together. I'm gonna bring this one over to the left-hand side. That would be 8TU minus WTU equals 20. Now when I add it together, the WTUs are gonna cancel and I'm left with 16TU is equal to 80. 16TU is equal to 80. Now if I divide both sides by 16, I'm gonna get that TU is equal to 5. Now if TU is equal to 5, then TD is also going to be equal to 5. But I still need to find something else. I am still missing solving for W. So what you need to do is you need to plug one of these back into either this equation here or this equation here so that we can solve for W. So if I look at this equation, I'm going to plug it into this right-hand equation. It says 8 times TU. So 8 times TU is 5 minus W times 5 equals 20. So I know that 8 times 5 is 40. So I'm going to move that to the other side, subtracting 40. Now I have negative 5W is equal to negative 20. Now when you divide both sides by 5, we get that the speed of W, the current or the water, is equal to 4. And that would be your answer. So it asked us, what is the speed of the current, which is W, and then it asked us for what are their times, which is TU and TD. So like I said before, you need to know both of these equations in order to solve. So let's look at the next one. The next one says the steamboat Juby fountain could go 70 miles downstream in 5 miles, but required 6 hours to go 48 miles upstream. What was the speed of the boat in still water and what was the speed of the current? So I'm looking for the speed of the boat and the speed of the current, both B and W. So what I'm gonna go through is on the first sentence, it says the steamboat Juby fountain could go 70 miles downstream. So my distance downstream is going to be 70. Then it says in 5 hours. So that means my time down is going to be 5. But required 6 hours to go 48 miles upstream. So that means my time upstream is going to be 6 and my distance upstream is going to be 48. So now I have my two equations that I have from the top of the paper. I have my downstream equation, which is going to be B plus W times TD equals DD. And then I have my upstream equation, that's going to be B minus W times TU equals DU. Now I'm going to input what I have. I don't have anything for B and W, so I'm just going to leave that B plus W times TD, which is 5, equals DD, which is 70. Now for this one, I'm going to have B minus W times TU, which is 6, equals DU, which is 48. And now what I'm going to do is I'm going to distribute the 5 and distribute the 6. So I have 5B plus 5W equals 70, and then I have 6B minus 6W equals 48. Now what I want to do is I actually want to do elimination. I want to be able to eliminate one of the letters. Now if I look, this one has a positive 5 and this one has a negative 6 attached to the W. So I'm actually going to eliminate the W by multiplying this equation by 6 and this equation by 5. So we're doing elimination. You also could have solved by substitution, but you would have had to divide and then solve for one of the letters. So that would give me 30B plus 30W equals 420. Multiply the other equation is going to be 30B minus 30W equals 240. Now, if you see, my W's are going to cancel. And now I'm going to be left with 60B is equal to 660. And if I divide that by 60, I get that B is actually equal to 11. So the speed of the boat is going to be equal to 11. But you're not done yet, because we still have to solve for the speed of the current. Now you can take this B and plug it into either this equation or this equation. It doesn't matter which one, either would give you the right answer. So I'm going to look at this equation on the right. It says 6 times B, which is 11, minus 6W equals 48. Now I know that 6 times 11 is 66, so I'm going to move that to the other side and subtract 66. So that would give me negative 6W is equal to negative 18. So divide your 18 by negative 6, and you get the speed of the current, or the water, is equal to 3. And that would be your two answers. Okay, and I said that I wasn't going to do number 92.3, but I'm actually going to do that one as well. So if you will flip your page to look at 92.3, this is the same type of problem using the same equations. We're going to go through this one as well, since there are 3 new problems in lesson 92. So this one says the water in Flint River flows at 5 kilometers per hour. So from the beginning of the problem, it says the water is flowing at 5 kilometers per hour. So right away, I'm going to say W is equal to 5. Then it says a speedboat can go 15 kilometers upstream. Okay, upstream 15. In the same time it took to go 25 miles downstream. So downstream is 25. And again, it said the time up is going to be equal to the time down, because it says the same time as it took to go downstream. And then we want to know how fast the boat is in still water. So we're looking for the speed, the boat. So we're looking for B. So now I'm going to go to my 2 equations. I'm going to start with my downstream equation. Again, I'm going to write this down. So it's B plus W times TD equals DD. And then I have my upstream equation, which will be B minus W times TU equals DU. Now the speed of my boat, I don't know, so I'm going to leave that as B. My W is 5. My TD is equal to TU, so I'm just going to leave TD as TD. And my DD is equal to 25. So now when I distribute the TD, I get BTD plus 5TD equals 25. On my other equation, again, I don't know what B is, so I leave B as B, but I have my W is 5. My TU, I'm going to change to TD, and my DU is equal to 15. So just like on the last one, I'm going to distribute the TD, which would give me BTD minus 5TD equals 15. Now, if we look at these 2 equations right here, if I were to add them together, we could actually solve for what BTD would be equal to, but we're actually just looking for what B is equal to. So what we're going to do is I'm actually going to eliminate the BTD, which means that I'm going to multiply this equation by -1. Now my left equation, I'm going to leave the same. So I'm going to leave it as BTD plus 5TD equals 25. And then I have negative BTD plus 5TD equals negative 15. Now when I add those together, notice that the BTDs cancel out. Because I want to just solve for one of the letters. I don't want to solve for the compound BTD. So this would be 10TD equals 10. So therefore, TD is equal to 1. But you're not done because they're not asking us for the time. What they're asking us is for the speed of the boat. So now we're going to take this TD is equal to 1 and we can plug it into either this equation here or this equation here to solve for the speed of the boat. It doesn't matter which one. I'm going to just do it into the left equation. So that would be B times 1 plus 5 times 1 equals 25. Now I know 5 times 1 is just 5, so I'm going to subtract 5 from the other side, and that would give me that the boat is equal to 20. And that is your answer. Now what I want you to do is I want you to try to work on number 1. So I want you to pause the video here, and I want you to try and work on number 1. And then when you're ready, once you've attempted it, then I want you to play the rest of the video. So for number 1, I'm going to go through it now. So if you have not tried it yet, please pause the video now. Number 1, Alonzo and Rupert could go 70 miles downstream in the same time it took them to go 30 miles upstream. If the speed of their boat was 10 miles per hour in still water, what was the speed of the current and what were their times? So I am given in the first sentence the distance downstream because it says 70 miles downstream. So my distance downstream is equal to 70. In the same time it took to go 30 miles upstream. So the time down is going to be equal to the time up. It also gives me the distance upstream was equal to 30. The speed of the boat was 10 miles in still water. So B is going to be equal to 10. Now I'm going to go to my 2 equations that I know. My downstream equation is B plus W times TD equals DD. And my upstream equation is B minus W times TU equals DU. So I'm going to input what I have. I know that my speed of the boat is 10, so that would be 10 plus W. I'm going to change my TD to TU, and DD is equal to 70. So when I distribute my TU, I'm going to get 10 TU plus WTU equals 70. Now I'm going to pause with that equation and I'm going to work on my upstream equation. So for my upstream equation, again, I know that the speed of the boat is 10. I'm going to leave my TU as TU and my DU is going to become 30. Now, just like on the last problem, I should distribute my TU, which would give me 10 TU minus WTU equals 30. Now, if you look at these 2 equations that we have here, one of them has a positive WTU and one of them has a negative WTU. So if I add those together, I'm going to bring this one over here. If I add them together, my WTUs are going to cancel. And now I'm left with 20 TU is equal to 100. And once I've done that, I can divide both sides by 20, which gives me that the time upstream is equal to 5. Now, if I know the time upstream is equal to 5, then I also know the time downstream is equal to 5 because they're equal. And now we're left with solving for what the speed of the current is, what the speed of W is. So now I'm going to plug it into this equation over here. I know that TU is equal to 5 minus W times 5 equals 30. Now I know that 5 times 10 is 50, so I'm going to move that to the other side. And that would give me negative 5W is equal to negative 20. So therefore, the speed of the current W is equal to 4. And that would be your answer. Okay, now I want you to pause this video so that you can try and attempt number 2 on this lesson. and then you can unpause once you have attempted it so that you can see how I do it. Number 2, the motorboat Alexis could go 60 miles downstream in 4 hours, but required 5 hours to go 55 miles upstream. What was the speed of the boat in still water, and what was the speed of the current? So number 2, I'm starting with the information they give me. It says could go 60 miles downstream. So that means the distance downstream is 60 in 4 hours, which means the time downstream is 4. But required 5 hours to go 55 miles upstream. So now we're talking about upstream, which means that my time upstream will be 5, and my distance upstream is going to be equal to 55. We're looking for the speed of the boat in still water and the speed of the current. So I'm looking for B and W. Just like on the last problems, I'm going to start with my downstream equation and then upstream. So for my downstream equation, I have B plus W times TD equals DD. For my upstream equation, I have B minus W times TU equals DU. So again, I don't know anything about B, I don't know anything about W, so I leave them as B and W. I do know that my TD is 4 and my DD is 60. So now I'm going to distribute my 4 so that you have 4B plus 4W equals 60. Now moving on to my other equation over here. Again, I don't know what B and W are, so you can leave them B and W. I know TU is equal to 5 and DU is equal to 55. So now you're going to distribute your 5. That will give me 5B minus 5W is equal to 55. Now I have 2 equations here. I have B and W containing B and W. Now you need to decide if you're going to do substitution or elimination. I'm going to do elimination, and I'm going to eliminate W. So because this one's positive and this one's negative. So I'm going to multiply this one by 5, this one by 4. And that would give me 20B plus 20W equals 300. This equation over here would also be 20B, but minus 20W. It's going to be equal to 220. Now, when you add these together, our W's are going to cancel because, again, one was positive and one was negative. When I add the B's together, I'm going to get 40B is equal to 520. And when you divide 520 by 40, you get that the speed of the boat is going to be equal to 13. But you're not done because you also have to solve for the speed of W, the current. So now you can either take this B and plug it into this equation or this equation to solve for what B is going to be equal to, or W is going to be equal to. I'm going to choose to plug it into this equation, so that will be 5 times 13 minus 5W equals 55. Well, 5 times 13, that's equal to 65. So I'm actually going to move this to the other side by subtracting 65. And that would give me negative 5W is equal to negative 10. And therefore, the speed of the current W is equal to 2. Okay, so that was number 2. Now I want you to pause this video here and I want you to work on number 3. Number 3. When you are done trying to attempt number 3, then you can unpause the video and work through it with me. Number 3, the water in the Kern River flows at 7 kilometers per hour. A speedboat can go 21 kilometers upstream in the same time it took to go 35 kilometers downstream. How fast can the boat go in still water? So we're looking for the speed of B. Now, they give us that the Kern River flows at 7 kilometers per hour. So that means the water is 7. The speedboat can go 21 kilometers upstream. So the distance upstream is 21. in the same time that it took to go downstream. So that means TU is equal to TD. In the same time it takes to go 35 kilometers downstream. So that means the distance downstream is 35. Now I'm going to go to my two equations. You always need to use both of them. So B plus W times TD equals DD. Then my upstream equation will be B minus W times TU equals DU. Now I'm going to plug in what I have. I know that the speed of the current is 7. My time down is equal to the time up, but I'm only going to change my TU to TD. So I'm going to leave TD the same. And my DD is 35. Now you want to distribute this TD. So that would give me BTD plus 7TD equals 35. Now I'm going to go to my other equation. Again, I don't know what B is, so I leave it as B, but I know that my W is 7. And then I have TU is going to change to TD, and my DU is 21. Now if you distribute your TD, you're going to get BTD minus 7TD equals 21. So now I'm going to look at my two equations. I have a positive 7TD and a negative 7TD. I'm actually going to add those together so I can eliminate the TD. So BTD minus 7TD equals 21. Now you'll see that the TDs cancel and you're left with 2 BTD is equal to 56. So therefore BTD is equal to 28. That's not what we want to solve for. We actually want to solve for what B is equal to. So now I need to take this 28 and plug it back in to solve for TD and then solve for B. So this one, if you do it this way, it takes a little bit longer to get to our result. So I'm going to plug in my 28. So I have 28 minus 7TD equals 21. Move the 28 to the other side. That would give us negative 7TD is equal to negative 7. So therefore, our TD is actually equal to 1. But again, that's not one of my answers. What I want to solve for is I want to solve for what B is equal to. So now I can take this and plug it into either of these equations here and solve for what B is equal to. I'm going to plug it into this equation on the right-hand side, which is B times 1 minus 7 times 1 equals 21. So I plugged it into this equation right here. Now move the 7 to the other side by adding it. So therefore B is equal to 28. And that concludes your new information from lesson 92. This lesson 92A, you need to post all your questions under this lesson by tomorrow morning at 9 a.m. on Tuesday. Please make sure that you attempt all your problems before you submit your questions, and I will talk to you guys later. I hope you guys all have a great Monday. Bye.